Okay, so in order to get ready for Wednesday, we got a lot of information to cover today.
Already?
Okay, go for it.
All right.
Not so many questions.
Put this up. It's useless.
Wireless networks. Wireless Internet communication, commonly referred to as Wi-Fi or wireless fidelity. Do you guys know that?
I didn't know that because I'm a freaking nerd. Proceed.
Okay, so did anybody except Colton know that?
I have a feeling you might have mentioned it before, but I can't remember. You didn't?
Enables devices to connect to a network without a physical connection. All key components and processes for secure wireless data transmission. The first wireless protocol, 802.11a, WEP wireless equivalent or wired equivalency protocol.
Oh, web.
People, yeah,
Oh, web. I know web.
web. People figured out how to crack that about 10 seconds after it was invented.
Yeah, WPA was the next one.
Yeah, I started seeing that.
Yeah, so basic components of Wi-Fi. Wireless access point, or AP, acts as a bridge between wired and wireless networks. Broadcasts wireless signals so that devices connect to it and manages data transmission between wireless devices and the wired network. So when, like I said, when Wi-Fi was first invented, commonly known as Wi-Fi A now. You have A, B, G, and then start getting up into the AX and so on. So when Wi-Fi was first created, it was almost, magic.
I agree with that.
For years and years and years, the only way that you could communicate with a computer was if they were physically wired together.
Your Wi-Fi is
And
ready.
then somebody decided, oh, hey, we can broadcast this out over a radio. And wireless communications has been a thing for, since the 30s or whatever, whenever Marconi figured out how to modulate an RF signal in the radio.
Thank you, Marconi.
You ever want to freak somebody out, tell them that you're going to go listen to your Marconian wave extrapolator.
Marconian wave extrapolator.
He was
wrong, but
he was a badass dude.
Marconian wave extrapolator. I like that.
Wireless network interface, or NIC. It's actually WNIC, not NIC, but NIC.
WNIC.
Nick.
Found in devices like laptops, smartphones, IoT devices. There are endless things that use Wi-Fi now. And that's part of the problem, is because in your Wi-Fi spectrum, the original anyway, the 2.4 gigahertz band, there's actually, there are 13 channels, 11 of which are legal in the US. Channel 12 and channel 13 are not.
What are those reserved for? Like, if they're illegal, doesn't that mean that there's something?
Well, they're illegal in the US. The rest of the world
Can use
12 and 13.
here. Are they like used for something here, and that's why they're illegal?
Yeah. FCC has those frequencies allocated for something else.
Probably one of them merged.
But let's say there are 11 channels and you can use any one of them that you want, but if you look at the spectrum, the radio spectrum on those, channel 1, channel 6, and channel 11 are the only three that don't overlap with each other.
Mm.
So 2, 3, 4, and 5 overlap both channel 1 and channel 6. And then 7, 8, 9, and 10 both overlap both 6 and 11. So, hey, I'm going to jump into, channel 3 because everybody uses channel 1 or, whatever.
Mm-hmm.
You're not doing yourself any favor because now you're getting interference from channel 1 and channel 6. So, that's one of the driving factors behind the 5 gigahertz band.
Indeed.
The wireless NIC allows devices to send and receive data over wireless connections, convert data between radio signals and digital data. So all you're doing is modulating the radio signal like you would with AM or FM radio or ham or whatever, any kind of radio communication.
Yeah, I learned that you can like cast like your hotspot over ham radio if you wanted to, and you can have like your whole neighborhood, you could have Wi-Fi in it.
Well, if you have a strong enough transceiver, you can broadcast it for miles and miles and miles.
Mm-hmm.
Well, yeah, I guess, yeah, because there's also the repeaters too.
You ever heard of a WISP?
Not the Scottish,
No.
ghost? Oh,
Like
no,
I've heard like a whip antenna, but no.
I've heard
WISP
of
is
this.
a wireless internet service provider.
Oh,
A
yeah.
buddy of mine is a WISP, and after my dad passed, I was helping him installing equipment at customer locations. And it wasn't nothing for me to be, 5 or 10 miles from the radio tower, the access point, and still be able to make a connection so people could have high-speed internet, in the boonies somewhere.
Is that kind of like how T-Mobile 5G Wi-Fi works?
Pretty sure there's
Well,
like,
the backhaul on the T-Mobile and Verizon, whoever else does, I'm sure AT&T's into it by now. That is a cellular connection. And then, of course, you have the Wi-Fi signals broadcast,
Yeah,
by the
router.
router. Yeah.
Because I have a router that you have to put it in like a window that's facing the nearest like tower, or else you don't get good reception, because like the back is like the antenna thing, so you have to like
Yeah.
angle it. But
Mm-hmm.
Okay. Key concepts and processes. Doesn't that sound like me? RF signals, wireless communication, uses RF signals to transmit data through the air. Tesla was a big one on that too. You guys ever heard of his Wardenclyffe Tower?
I have,
Mm-hmm.
the thing was supposed to transmit a
A
lot
real
of other
Tesla
stuff.
guy,
Yeah,
not,
Nikola Tesla.
Nikola
Yeah.
Tesla.
oh yeah, I heard of
He actually figured out a way to broadcast electricity.
Wirelessly, the old
wireless.
Tesla coil.
That's why he invented the Tesla coil.
That's why I had the boat,
Yeah,
the show, the famous show that
yeah.
he made a boat.
Mm-hmm.
Friend of mine, he was a volunteer firefighter, and he put a linear amplifier on his CB radio, and he was also the DJ at the local skating rink. He said, hey, he pulled a fluorescent tube out of the back seat of his car. He said, walk over to the other end of the parking lot and hold it up. Okay. He kept his microphone and the light was light up.
That's crazy.
That's whack.
Same basic idea.
I've thought about
Wi-Fi signals operate on 2.4 gigahertz and 5 gigahertz. bands which are regulated by the FCC.
802.11.
Yeah. 802.11 is what defines wireless communication as far as Wi-Fi is concerned.
Does these things affect our health in any way? I never asked this.
No, I'm pretty sure they don't.
Do I?
Does these signals, transmitting these signals at certain frequencies or whatever, does this ever like transmit, or affect our health?
Oh, yeah.
Like even
Wait,
the
really?
satellites transmitting certain things, like.
Really? I was
I
having
mean,
If you could see in the radio spectrum, everything would be a complete garbled mess. You wouldn't be able to
You see, right, there's so much.
see anything because of all the interference.
That's
Any kind of electromagnetic radiation, it has got to affect you in some way.
Oh, that's very interesting.
You know, it's like you see the TV shows where, investigate reports or whatever, and the people that live near the high tension power lines, their kids have an elevated rate of cancer and all kinds of crazy.
Yeah.
Wow, really?
Yeah. Same thing.
Oh.
Electromagnetic radiation is electromagnetic radiation.
It's radiation, yeah. Just,
Even at the really low frequencies, at low energies?
Well, frequency does not equal energy.
Well, yeah, I know, but there is also, there's low, high frequencies and low and high energies. I consider these separate, by the way.
exposure for a long time, even at low, it's the
Low
same
frequencies.
thing. You get exposed
Okay,
to-
wow, that's something to think about. I was always told that wasn't actually, okay, well.
That's what they want you to believe.
Yeah, like if you walk around like this all the time, you're gonna get a tumor in your brain
Tumor in the brain, maybe an ear infection even? Nah, an
and,
ear
well, I guess
infection.
if you don't clean the phone,
Yes.
you might get an ear infection.
Wow.
Okay, so channel selection and interference. Wireless networks divide the RF spectrum into channels. Devices and access points select channels to minimize interference from other devices and networks. I have, it's injured. I have an app on my phone called Wi-Fi Analyzer. I don't know if it helps if you turn the Wi-Fi on.
Have you ever used that thing you plug in?
Okay, so there, I don't know why you guys can see that, but there's, access point after access point after access point. And it'll pop up, if you let it sit long enough, it'll tell you what channel they're on. So whenever you're wanting to set up your Wi-Fi at home, if you're having problems with not interference, sort of causes it, but poor throughput, your speeds aren't what they're supposed to be, or you have a lot of retransmits because the data gets corrupted or whatever. Run a scanner and you'll see all the access points around you that are broadcasting. You want to find the one with the cleanest signal. Right now, there we go. Each one of those different colored humps is another access point.
And is each
that my phone is detecting right now. OTC guest and OTC Wi-Fi are on separate channels. Actually, there's a bunch of them. There's channel 1 and channel 11. Clinic 2.4 is broadcasting on channel 9, which is overlapping 6 and 11. Well, way you guys can see that from back there.
A yellow.
The Then all of these, they're all on channel 1. Those are absolutely interfering
Oh,
with each
it
other.
just went down.
Yeah, they're absolutely interfering with each other.
Mm-hmm.
Or you can see, the newer systems are more dynamic. So if there's a lot of interference on one channel, it'll automatically switch to another. Did I tell you guys about, I think I did, any access point that you've ever connected to, your phone remembers it and is constantly trying to reconnect to it?
Yeah.
The way that works is, even if I am in range of the actual access point, like Walmart or whatever, well, if you want to hijack my signal, you can say, hey, whoever is connected to Walmart's access point, I am a much stronger signal, and your phone will prefer it, even though the real one is in range.
Oh, yeah. You can do that with your service your phone provider. You can connect to different towers if you search for
Yeah, sometimes.
search for networks. Yeah, I used to be able to do that a while, like long time ago. Like with T-Mobile, it lets you connect to like different ones, and it's usually like faster. Like internet, if you go to your settings and
Yeah, it's, your phone is automatically going to connect to the strongest signal that it can see. But that doesn't necessarily mean it's going to be the best signal. The strongest does not equal best.
Mm-hmm.
It's all a matter of how much interference is between you and that signal. Signal to noise ratio. You ever heard of that?
Signal to noise ratio.
Yeah, signal to noise ratio. That is a measure of how much of the signal that is on a particular frequency is a good signal and how much of it is garbage.
Don't they used to do that too, like in control cabinets, have this little gadget, what it does is transmit the signals for like part of the, I don't know. I saw a guy building a control cabinet and he had it in the control cabinet, he says, called a radio or something.
There are,
He said they don't use it no more or something like that in the industrial application.
it depends on the application. All the water towers and whatnot that are around town, those all have Wi-Fi on them. And it's not so that you can access, but so that they can talk back to city utilities and tell them what the level of the tank is. They can also monitor the terminal lift stations, which is, shit runs downhill.
Yeah.
Well, it goes so far downhill and then you gotta pump it back up so that it can run downhill some more. Pump it back up, run downhill some more. That when you pump it back up, that's what's known as the terminal lift. So they have to monitor those all the time, because if one of them goes down, shit everywhere, literally.
How much of it, like, what kind of fail safes do they have in place for that? Is there like big storage tanks that, or like big reservoirs that each thing, so it
I
doesn't?
don't know how big, but yeah, they're not like the pump is running all the time. But they do monitor the health of it. SSID, that is the Wi-Fi name that you see on your phone whenever you want to connect to whatever. Each wireless network has an SSID or a unique identifier. You can name your SSID whatever you want. So, if you wanna call your, whatever, Walmart's is. So people come, drive by your house or whatever, their phone goes, hey, I'm at Walmart. You can. Not sure why you would want to, because then they're using your internet. But the devices use the SSID to identify and connect to specific networks. That is also a network interface connection, which includes MAC. So you can actually say, hey, this SSID is attached to this MAC. So if I want to connect to this SSID and it doesn't have that MAC address, don't connect. So, MACs are globally unique, right? You can spoof them, but authentication and encryption, Wi-Fi networks use security protocols like WPA2 or WPA3. I said, about 10 seconds after they came up with WEP, it was compromised. I mean, you can hack a WEP network in literally seconds. So they came up with the WPA.
Wi-Fi protected access.
There you go, thank you. And then, WPA2, which uses different algorithms for data encryption. And nowadays they have WPA3 because, you guys ever heard of Wi-Fi 6 or Wi-Fi 7? Instead of having one connection to the access point, your phone actually makes dozens of them. It goes on Wi-Fi 6 or Wi-Fi 7, and it multiplexes the traffic. So it sends a little bit of this, a little bit of that, a little bit of this other thing, one right behind the other, and the protocol keeps track of which packets are which. So it knows how to reassemble them and gets the other end. And it's really crazy technology. They can use what they call, they can use what they call beam forming, where, if the access point is, there, and my phone is here, it knows that it's going to direct the signal to my phone to give it the best possible connection. If I move over here, or if I move over here, that beam is going to follow me. So my phone always has the best connection possible. How it does it, don't know. Really cool technology. I'm thinking voodoo. Authentication ensures authorized access. I don't know how much it ensures authorized access, because you can hack a Wi-Fi network, which you guys are going to find out on Wednesday how easy it is.
Oh, how it finds you, it can be easy. It's kind of like the automatic guided vehicles. That's what they have on them. That's how they're able to stop.
It's omnidirectional Wi-Fi signal though.
Like it moves like a motor.
Omni means all around,
It just, the
360.
Transmission pattern is a circle.
Oh, so you can go all around and it's kind of.
Go anywhere around the access point, still get a signal. So how does it know that my phone is there and not over there? And I'm not the only one that works for you. Everybody in this room
For everyone, right?
can connect to the same access point
And then follow you.
and then follow everybody at the same time. Voodoo.
I'm not even about to look into that because I'll have a headache trying to, no, I'm good.
Yeah. The main thing about Wi-Fi nowadays is the signals are actually encrypted with either AES or TKIP, sometimes both. Data transmission devices communicate via packets similar to wired Ethernet. It's exactly the same as wired Ethernet. The only significant change is MAC address. It still uses the OSI model, so it gets from the application layer down till it gets to network, and then instead of going across a wire, it's turned into radio waves. That's your layer one. Packets include headers, which are source and destination, and payload. Transmitted as modulated RF signals, just like any other radio signal. Roaming. Devices can move between different access points within the same network. It's like here on campus, if you connect to the OTC Wi-Fi and move about campus, you're not staying connected to the same access point all the time. They operate in a mesh style network.
Oh, so why did phone companies charge you if
Because they can.
Huh?
Because they can.
That is crazy.
Well, cellular network roaming is different. If you're roaming on a cellular network, you're using somebody else's tower.
Oh, so you're not using.
So if you're a T-Mobile customer and the closest tower with correct technology belongs to AT&T, you
You can use
know,
it.
AT&T allows you to use their tower, but they charge T-Mobile for the airtime, and that gets passed on to you because T-Mobile's not going to pay AT&T shit.
Oh, okay. Because I was just thinking, that's their tower, and they're just charging you money. Oh, okay.
Yeah. Anyway, the whole roaming thing, as you move about campus, it always connects to the strongest signal. That's how one of the attacks work. You set up shop in Starbucks or whatever, and you turn on your sniffer, and everybody's phone is saying, "Hey, I want to connect to Walmart or widgets access point, whatever they are," and you as the hacker say, "Well, that's me, that's me, that's me, that's me." Or you can just, hey, I only want to connect to Starbucks Wi-Fi. As long as I'm transmitting a stronger signal than Starbucks' actual access point is, I get your traffic. So I become man in the middle.
Oh.
So you connect to me and I connect to Starbucks Wi-Fi. And I just pass your traffic through, but I record everything that goes through my deal, right? Roaming protocols, 802.11k and 802.11r ensure seamless connectivity. So as you're moving about campus, the Wi-Fi knows that whenever you get out of range of this access point into the range of this one, it's going to seamlessly transition from one to the other. You don't have to disconnect here and reconnect here. It's totally seamless as far as you're concerned. You don't see a drop in signal or connection or anything, because the access points are all talking to each other. Communication flow. Devices scan for available networks and choose one connected based on signal strength and security settings. Key part of that is signal strength. By default, Wi-Fi devices will always try to connect to the strongest signal that it can. If your neighbor is blasting his Wi-Fi signal and just drowning yours, you're not going to connect to his because you don't know what his passphrase is, right? It still affects yours because he just blasted it.
And it usually shows the strongest to the lowest signal when you like search up the signal, it shows you the strongest first.
Yep. Send an association request to the chosen access point. So, I actually turn my Wi-Fi off when I'm not at home, because I don't want my phone saying, "Hey, home, Wi-Fi, where you at?" all the time. But when I get home, turn my Wi-Fi back on, and it says, "Hey, home Wi-Fi, where you at?" It says, "I'm right here. Can I connect?" "Yeah, sure."
Wait,
"What's your MAC address?"
if you turn your Wi-Fi off, it doesn't do that, like, hey, where are you?
Yeah.
Depends on the phone. Sometimes, not always, but sometimes the phone will actually turn the Wi-Fi on and say, "Who's out there?" And then shut itself back off, and you don't even know it.
Well, I think my phone does that because, I reset my phone, and while I was setting it back up, a couple of days after I got it set up, I got a notification that said like, I turned my Wi-Fi off, and it was like, we'll automatically turn your Wi-Fi back on when you're near a strong, trusted Wi-Fi connection that you use often or something like that. And it just.
Yes, because periodically it says, "Are you there?"
Yeah, what the heck?
"No?" "Okay. Go back to sleep."
It's nice, it saved my ass because I pay for my phone service and I'm cheap, I don't pay for very much data. So, you know, I'll be out and I'll have my Wi-Fi off because I don't want to connect to, you know, random stuff that I've connected to before. And then when I get home, I forget to turn my Wi-Fi back on, and I like eat through my data.
Yeah, I know.
Yeah.
I know about that too.
There are ways to automate that based on geolocation.
Yeah.
It's your updates. You see when you it'll give you an option to update over a Wi-Fi network or use your data to update the phone. You can.
Well, that's for, operating system updates for the phone itself.
Yeah, and I definitely don't want to download those
Update
over my data because
data, yeah.
it's a lot.
Yeah.
So it'll wait until you connect to a Wi-Fi and it'll start installing updates. So there's a little check mark you can unmark and it won't do no updates at all. You won't turn, because it will try to turn your Wi-Fi on to update the phone. I remember I had that on.
Well, like Cole said, it's going to turn your Wi-Fi on periodically just to see if that strong signal that you normally connect to is in range.
No matter what, it does that.
Well, you can say no. It's going to do it anyway.
Yeah.
It just won't automatically connect to it if it finds it, unless you physically turn it on. It's constantly probing. "Are you there? Are you there? Are you there?" Well, not constantly, but it's periodic. Once every 10 minutes, once an hour, whatever that time frame is.
I know exactly what he's talking about, because I used to be like, what? Why do I need data, man?
Yeah.
And I used to have the prepaid phone, just trying to update and like.
Yeah.
Data.
Authentication, the devices authenticate themselves using pre-shared keys, WPA, WPA2, or other methods. PSK is the most common nowadays. The access point is set up with some passcode, passkey, passphrase, depending upon which manufacturer you're talking about. It's all the same stuff. And you have to say, I want to connect to, OTC's Wi-Fi or whatever, and then it says, "Hey, what is your passkey?" You type that in. If it matches, it allows you to connect, and if not, it says, "Sorry about your luck, can't authenticate you." So, access points verify credentials and grant access if authenticated. So it's the access point itself that does that authentication, which is why it's easy to steal credentials. Data transmission. Once connected, devices can send and receive data packets, which, it's kind of hard to send and receive if you're not connected. Access points manage data flow between wireless devices in the wired network. That is the sole purpose of an access point, is to generate that Wi-Fi signal that allows you to connect to it, and then it does the translation from radio signal to wired. Disassociation. Devices disconnect from the network when moving out of range or explicitly disconnecting. That's one of the ways that the Wi-Fi hacking works, is you tell everybody to disconnect, and they go, okay. Or you say, hey, I need you to reassociate. So it disconnects, and whenever it tries to reconnect, it says, okay, here is the SSID that I want to talk to, and here's the passkey. So while it's doing that exchange, you're sniffing the traffic, and then you can use the tools that Gabe's going to show you on Wednesday, how to decrypt that information and figure out what the actual passkey is. Because it's not sent in plain text, but it is sent with a known encryption.
Yeah.
So you have to be able to decrypt on both ends. Right, so you do that man in the middle thing, and you do the decryption.
Yeah.
Once you know what that key is, you're on the Wi-Fi. You do whatever you want with it.
Man in the middle has a lot of applications.
Yep.
Yeah.
Lots of. Access points release resources associated with the device when it disassociates after a certain period of time. That's what that doesn't include. When you drive away from your house and you're no longer connected to your Wi-Fi, or you just straight turn it off, the access point will wait a little bit, because you may have just ran to the mailbox or whatever, and you're going to be right back. It doesn't release the resources for your connection until a predetermined amount of time, and then it says, okay, well, obviously he's not coming back, so I'm going to let go of the resources so somebody else can use them.
Sound like forgetting the network.
No,
Forget it.
no, forgetting the network just means you're not storing the connection information in your device. Now, the access point has a limited amount of bandwidth available. So if it's constantly trying to maintain a signal with you and you're, 100 miles away, it can't. So, if Colton wants to come in and use the Wi-Fi, he can't, because you're using all the resources and you ain't even around. At your home, you're not going to see that. It still works the same way, but you're not going to see that. If you go to Starbucks or Walmart, someplace where there are lots of people connected all the time, that's when it becomes important. Because if it holds on to every connection that's ever made to it, it doesn't take very long until it won't accept any new connections. You might stop by Starbucks, use their Wi-Fi for 5 minutes, check your email, and never go back ever again. So why should it hang on to the resources that are allocated to you if you're never going to show back up again? Make sense?
Right, and I mean, that thing just sits on your phone too every time it's not connecting to anything. So.
Mm-hmm. That's why you want to go in and periodically clean those out. Advantages and considerations. Main advantage is mobility. Devices to connect and move within the network coverage area. Can you imagine having to have the cord connected to your phone all the time? Like us cavemen, Drew and I. How many of you guys have actually seen a phone with a cord on it?
Oh, yeah.
Like a charger cord?
How many of you have actually used a phone with a cord on
Yeah.
I mean,
I use a phone with
it? The rotary dial, yeah.
Okay, not that old, not one of these.
Yeah.
No, but I
Yeah,
have
I
one.
was, I don't know, 12, 13 years old when the town that I grew up in finally got touchstone service.
Like what you have on your desk?
Yeah.
Oh.
Well, that's a VoIP phone, voice over IP. So technically it's corded, but you can't. Of course, they got this with tight down, so you can't record that for this. So,
So you can use VoIP on those? I thought VoIP was only like an app on the phone or something, or, so you can use it on like landlines?
that's not a landline.
I mean, it's a VoIP, but I'm saying like, like what they call those phones. Wow, I did not know that. So you can have like free, phone. I mean, it's VoIP, right?
You have to have a connection to the actual phone network for it to work. But that right there
Oh,
is an 8-pin Ethernet cable.
Voice over IP.
This one actually has 2 ports in the back of it. One of them is the PoE VoIP connection back to the network, and the other one is pass-through, so you can plug this Ethernet cable into your phone, plug your computer into the phone, and the computer will talk through the phone to the Ethernet.
And I always wish my computer had to talk through my phone.
That matters which port you put in.
They're labeled.
Okay.
Well,
So why would you want your phone to talk through your?
because then you only need one Ethernet cable. If you only have one Ethernet port in your living room,
Oh,
you want to connect your phone and your computer.
I see.
No wires, that's the beauty of it. Security measures are critical to prevent unauthorized access to data breaches. That's also a easy way into a network so that you can steal data or whatever is hit wireless. Protocol, security protocols, WEP, WPA, WPA2, designed to secure wireless networks from unauthorized access and ensure data confidentiality. Don't use WEP ever. It is way, way, way too easy to crack. My 8-year-old grandson can crack it.
Whoa, really?
Yeah.
You taught him how to, or?
No.
You figured out?
He watches YouTube.
Oh, okay.
oh,
Yeah, you can learn everything from YouTube.
Wouldn't be at all surprised if my 2-year-old grandson could do it.
Mm-hmm.
Key differences do exist in encryption strength and security features between WEP and WPA. So WEP provides encryption for wireless data. Authentication requires devices to access the network. And security weakness, less secure, using a static encryption key that can be easily cracked. The WPA Wi-Fi protected access improves on WEP weaknesses by using a dynamic encryption key via temporal key integration protocol, or TKIP. Supports various authentication methods like PSK and extensible authentication protocol, or EAP. WPA2 uses AES encryption for enhanced security, provides stronger protection, and is the standard for securing Wi-Fi networks nowadays. Backward compatibility, WPA2 devices can connect to WPA or WEP. It says WEP is not recommended.
for sure.
PSK is a passphrase shared between access point and client devices. You have to know it is pre-shared. You have to know what that key is before you can access it. it is chosen by the network administrator during the setup. So, the PSK that I use on my network is one that it is extremely unlikely that anybody would be able to actually guess. So you'd have to do what you learn on Wednesday to get into my network.
Oh, you got a whole key. You don't even need you got it in your pocket.
Well, to access my Wi-Fi, the hardware key doesn't matter.
Oh,
Yeah, you're talking about like your password, right?
no,
Oh, that's my password.
Lawyer blood, 42069.
Oh, so that has nothing to do with your network.
PSK is configured into the AP, client device is configured the same. PSK and network wireless network settings. The device sends an authentication request and the AP verifies the PSK. I said you disassociate whenever you're doing an attack, you disassociate everybody and they try and reconnect. Well, during that handshake is when you can grab the PSK, because that's the only time it's transmitted, is whenever you're trying to connect.
That's cool.
Management and encryption. Session keys, temporary encryption keys are derived from the pre-share key to encrypt the data. Every time you disconnect and reconnect, you get a new session key. All data transmitted between the client and the access point remains secure through encryption. Advantages of PSK is easy to set up. PSK authentication is simple to configure. When strong, PSK provides robust protection against unauthorized access. So again, if you have, like we talked about the other day about passwords, if it's blue or, fragistat, whatever, a word that's in the dictionary, it's gonna be a lot easier to crack than if it's 374 capital TX, exclamation point, whatever. Strength depends on the complexity of the passphrase. It says passphrase there, and you can actually have use words out of the dictionary and just jumble them up, like green pass, dog drive, whatever. Like, scrunch them all up as one word, put spaces between them, whatever. The chances of somebody being able to figure out those 4 words in that order, use uppercase, lowercase, and all that good stuff too. But, the more barriers you put between me and your network, the harder it's going to be for me to get into it. And, like whenever we do the intruder drill, first thing we got to do is lock the door, because if an intruder finds a locked door, they're more apt to continue on to try to find an unlocked one than they are to try to come through the locked one.
So a 4-digit passcode is easy to crack.
Oh, yeah. It's only 10,000 possible combinations.
Yeah, it's only, 10 to the 4th.
So the only way to secure it is to make sure that a person attempts to make it secure, like a 4-digit passcode. If you want to make it secure, you got to limit the number of attempts one can attempt to hold.
Well, yeah, that's one way to do it. The other way is to use something like 4 distinct words, or just, a bunch of random numbers and characters and whatnot. Key distribution, a secure distribution and periodic changes to maintain security. Good idea for you to change the passcode for your Wi-Fi periodically, just like you're supposed to change your password for your email and stuff like that. Connecting advantages and disadvantages of wireless connectivity and industrial production networks. Mobility and flexibility. The advantage, wireless connections allow for greater mobility of devices and equipment supporting dynamic production processes. So, place that I worked at in St. Louis, depending upon what product they were running, they would move punch presses in and out because they had to they use different dies and whatnot for forming and punching holes and whatever. None of them were connected to the network, but if they were, you'd have to be able to move them around, unplug from one, plug into the next one. If the connection for the first one is on this side of the machine, the connection for the second one is on this side of the machine, you have to be able to get the cable from one side to the other and all that stuff. Just do it wirelessly, you ain't gonna worry about it.
And these devices, they need a NIC on them, like a wireless NIC. If they don't, you can't.
Yep. Example, mobile robots, handheld devices, portable diagnostic tools, freely move around the facility. Ease of installation and scalability. Wireless networks reduce installation time, cost, and offer scalability for integrating additional devices without extensive cabling. Every time you put in a new machine, all you gotta do is hook it up to the Wi-Fi instead of running Ethernet cable to it. Adding new sensors or actuators to the production line without disruption. Cost efficiency, wireless networks can be more cost effective, particularly in retrofitting existing facilities. It's a lot easier to broadcast a Wi-Fi signal than it is to run a whole bunch of cable. Example, avoiding costs associated with trenching and cabling in large plants or outdoor installations. Remote monitoring. Wireless connectivity enables remote monitoring and control, enhancing efficiency and supporting predictive maintenance. I was talking earlier about the water towers and terminal lift and all that. That's all done wirelessly. Reduce downtime and reliability. Wireless redundancy and failover mechanisms can improve reliability and minimize downtime. So, if you have a failover network, if one access point goes down, the next one just picks it up, so you don't lose your connection to your data historian or whatever it is. Disadvantages, security risk. Wireless networks are vulnerable to unauthorized access, data interception, and cyber attacks. Encryption and authentication are essential. Also, you want to make sure you periodically change the passcode for the network. So just in case it gets compromised, it's going to change, so then they have to re-compromise your network again. Interference and signal degradation. Industrial environments often have EMI, electromagnetic interference from machinery, which can degrade signal quality and reliability. Especially if you have VFDs in the building, because they're gigantic radio transmitters. They put a huge amount of electrical noise into the air. Bandwidth limitations, lower bandwidth compared to wired connections, affect speed and data volume, potentially limiting applications. That's not so much the case anymore. You can get Wi-Fi signals that'll go even faster than some wired connections without a problem. Latency and network congestion. Latency and congestion can occur in dense environments with multiple wireless devices. So if you have a whole bunch of devices trying to connect to the same channel on your Wi-Fi, they start interfering with each other, cross-talking and whatnot. Carrier sense multiple access with collision detection or collision avoidance, depending upon which one you're using. Wi-Fi works the exact same way. It has to listen for a chance to transmit. If you have a really noisy or really busy network, then you can't transmit as often as you need to, whatever. Compatibility and integration, disadvantage. Integrating wireless devices with legacy equipment may require additional hardware. It's not as difficult to add Wi-Fi to equipment nowadays because it's been around a long, long time, several decades. That's usually not as big of an issue. Why use wireless? Offers flexibility, mobility, cost efficiency, but it also introduces risks. So robust security measures, site surveys, and appropriate wireless technology help maximize benefits and minimize drawbacks. So you want to figure out how strong your network is. I'll see how secure your house is, hire a burglar. Pros and cons of 2.4 and 5 gigahertz. Wireless networks nowadays operate on different frequency bands, primarily 2.4 and 5. Each has unique advantages and drawbacks, making them suitable for different applications and environments. 2.4 pros, better range and coverage because of longer wavelengths that allow 2.4 gigahertz to penetrate walls more effectively.
Right.
I knew it.
Providing better coverage over a larger area. You drop down into the 900 megahertz range, which is available. You can blast through trees and,
900 megahertz for your Wi-Fi?
Mhm.
Oh.
Megahertz is lower than gigahertz.
100
Yeah.
cycles per
So, I
second,
mean-
if that's right.
So the lower it is, the higher,
Million, yeah.
the lower it is, the higher you can transmit or something?
The farther.
The lower the frequency, the better, like, obstacle penetration it has. I don't really know how that works.
I mean,
Well, the higher the frequency, the closer the shorter the wavelength is, the closer the peaks are on your sine wave.
Yeah.
So if you have 2.4 gigahertz, you're talking millimeter waves. So they're about that far apart. When you pass through the wall, there's a better chance that the energy from that wave is going to come into contact with something that will either deflect it or absorb it.
Right, yeah.
Okay? Because if your wall is this thick and your wavelength is only this wide, you're going to hit, several bits of wall on the way through. But if you're down at 900 megahertz and your wavelength is a couple of inches.
Which is that true?
Yeah.
Like, okay.
Wavelength is 1 over frequency.
1 over frequency?
Okay.
Okay.
So the lower the wavelength or the lower the frequency is, the higher, the longer the wavelength is.
Peaks, yeah.
So rather than hitting stuff in that physically makes up the wall several times on the way through, the shorter or the lower bandwidth or the lower frequency is going to have a longer wavelength on it. So
Okay.
it's going to, pass on through as it's.
So it can go.
Has less chance of running into stuff that's going to absorb it or deflect it.
I'm pretty sure
farther
the
on those
shorter,
energy.
you could probably store more information in the what was it? The
Shorter wavelength.
yeah, the shorter wavelength signals and the higher frequency signals. Is that
We haven't
right?
gotten that far yet.
Yeah, what's the benefit then to using the higher frequency?
We haven't gotten that far yet.
Yeah. I'm on the right track, so that's nice.
Compatibility, 2.4 supports a wide range of devices, ensuring broad compatibility. Interference, more tolerant of interference from non-Wi-Fi devices. Nowadays, that's getting harder to do because Bluetooth and Wi-Fi both share the 2.4 gigahertz band. 2.4 cons, congestion interference, often crowded with many devices leading to interference and reduced performance. Limited bandwidth, fewer channels, 3 non-overlapping may lead to bandwidth issues. So 1, 6, and 11 are the only ones that don't overlap with any other channels.
What is bandwidth? I know it's like a weird question to ask now.
No, it's not. Bandwidth is the size of the pipe that you're able to send data through. So you have low bandwidth, you've got a pipe this big. If you got high bandwidth, you got a pipe this big.
Oh.
You know, you can cram a whole lot more through this than you can through that, right? I mean, that's
So the speed.
the juvenile way of explaining it, but
Yeah, I get it. Because I've asked somebody before and they say, oh, you're talking about bandwidth. You're talking about speed or bandwidth. And I'm like, I'm thinking it's the same thing, but.
well, the bigger your pipe is, the more data you can cram through at the same amount of time, so it manifests itself at higher speed. You know, if we need to empty this entire room all at the same time, when we hit the door, it's a bottleneck. We can get 1, maybe 2 people through at the same time. You know, you try and cram you and Colton through at the same time, it's pretty easy because you're both pretty skinny guys.
Yeah.
Me and Drew trying to get through there at the same time, that's not happening. But you knock out that whole wall and make that the opening, we can all get out at the same time, no problem. Okay,
I get it.
that's how bandwidth correlates to speed. More lanes on the highway available to you at the same time.
Speed up, right, yeah.
And then slower speeds provide slower data transfer rates compared to 5 gigahertz. Because the 5 gigahertz signal is higher frequency, it propagates at the speed of light no matter what. But because you have more up and down cycles, you can jam more data in the same space, which then again equates to faster. Higher speeds, it supports higher data rates, ideal for high bandwidth activities like HD streaming and gaming. Any of you guys ever do gaming over Wi-Fi?
I mean,
I do.
I was connected to Ethernet.
not always.
I mean, why?
It's usually connected to the Ethernet, but.
I feel like over the Ethernet, it's just a little bit
Oh,
faster.
no.
Yeah, it is a way.
If you're on a 2.4 gigahertz Wi-Fi versus wired, the wired is absolutely faster. 5 gigahertz Wi-Fi versus a wired connection could go either way depending upon the wired connection. Because nowadays you have gigabit, which is old technology compared to what we have today. Jump up to 2.5 gigabits or 10 gig. And fiber technologies, you can go even higher than that. Five gigahertz offers less congestion simply because there are more non-overlapping channels. So less interference. Fewer non-Wi-Fi devices operate on this band, reducing interference. There's also fewer devices, Wi-Fi devices, that operate 5 gigahertz. More available channels and all that stuff. There's over 100 channels on 5 gigahertz. And 23 of them don't interfere with each other, they don't overlap.
How much difference in frequency does there have to be for it to be considered its own channel?
It depends on the width of the channel.
So like a range?
Gigahertz cons. Shorter range and shorter or poor penetration, shorter wavelengths result in shorter range and limited ability to penetrate walls. Because
It is
your
disgusting.
your oscillations are much closer together, so there's even more chance for the signal to run into something in the wall that's going to either deflect it or absorb it.
It's gonna be hit.
Mhm.
The wall is thicker.
It also depends on what the wall's made out of, and, you know, some other factors, but I broadcast 2.4 and 5 gigahertz in my house. All of the phones and smart TVs and everything is connected to 5 gigahertz. And then all the IoT stuff, the light switches and whatnot are on the 2.4. And all the cameras are wired. Limited compatibility, older devices may not, probably don't support 5 gigahertz. And higher power consumption. Devices on this band typically consume more power, affecting battery life. Because in order to generate a 5 gigahertz signal, you have to physically put more energy into the signal to get it to oscillate at that higher frequency. You know, light that we can see is one energy level, and then you step up into ultraviolet, get into X-ray. X-ray has enough energy to actually pass through your body, where visible light does not. It can only go so deep and it gets stuck, right? Once you get up above X-ray, you start getting into gamma rays. In order to generate a gamma ray frequency, you have to do stuff like blow up stars.
Wow.
Take two supermassive black holes and smack them together. All kinds of crazy things that are really, really, really insanely high energy events.
The antimatter.
Yeah, matter antimatter reaction.
Yeah.